Hello, good folks. My name is Bob Hurst, and I'm with Better Way Training, BWT Inc. I have been asked to go ahead and then do a series of videos to give some training on multimeters, their usage, how to test electrical circuits with them, what to look for, and things of that nature. And that's what this series is going to be about. Today's lesson is really nothing more than the first of the series, and it's going to describe just a little bit about what we need to know before we even get into it, which is fundamentals, and that's safety. So if you notice, I am wearing a natural fiber shirt, which is required by, the NEC, National Electric Code. Before we go ahead and do electrical work, is we need to have a fire retardant shirt. And the reason is if it's fire retardant, if there is an arc flash or if there's a short, and everything else, if you've got a nylon shirt is going to sit there and it's going to burn into your skin, and it's going to take all kinds of stuff. Natural fibers don't burn into your skin. So that's one safety factor that you need to go ahead and address. The other is when we actually get in and I start demonstrating things on live circuits and everything, I'm going to have electrical rated eyewear safety glasses. So the other thing that we need to have on the circuit and testing is we need electrical rated gloves. So, the rubber part of the glove is actually the electrical part of the rating, but you want to have the leather part to go ahead and protect the plastic or the rubber part so that it doesn't get punctured. Anybody that's done any electrical knows that, wires, you're going to go ahead and have strands sticking out here and there, and they can puncture these, which if there's a hole in it, it goes ahead and it allows you to still get shocked. So that's why you want to go ahead and test them, make for sure that they, don't have any leaks in them before you go ahead and get in there and start doing some testing. So anyway, now that safety's out of the way, I want to go ahead and address the fact that what we want to do with this series is teach you what you want to look for in the different components and how to understand it, and the different types of meters and the ranges and everything else. For instance, this meter right here, it's a clamp-on meter. So, obviously, we can sit there and clamp on the wire, and then it can measure the current that's going through it and everything else. Plus, it has a few other options, voltage, resistance, and everything. It's not as accurate as some, but the rating is only 240 volts. So if you're in a plant that has 480 volts or higher, this meter right here should not even be in your toolbox, because you can reach in there and grab it and then go ahead and start testing, a 480 volt circuit with a 240 volt rated meter. That's a maximum capacity they can handle, and that can get you in trouble. So you've got to know what you're going to be testing, and you got to know what your equipment's capabilities are and what its ratings are. You take this one is class 4, 1000 volt rated clamp-on meter. So, it goes up to 400 amps. So, you've got to know the ratings and everything. There's other items and functionalities. Okay. And then the different testing, you take this one, it tests AC voltage, DC voltage. It tests temperatures. It tests hertz. It tests capacitance, resistance, continuity. It tests all the way down to milliamps, and it tests amps AC or DC. So, this is a multimeter right here that has several different functions that you can test on an electrical circuit to really do some serious troubleshooting and everything. And it also has a hold It has a min max and it has a range. So this one automatically, if you just go ahead and set it to volts and you hook it into something and it's got 1,000 volt rating, as long as it's below 1,000 volts, it will automatically give you the best range that you're going to go to right here to read it, to be the most accurate. So, that's a good plus. This one, on the other hand, it's just as accurate as that other meter, but it depends on you knowing what kind of circuit that you're dealing with and everything else, because you have to know the range. If you don't know the range, you want to go ahead and you start out at the highest range and work your way back. And but this meter right here is just as accurate as the fluke meter I just showed you. So anyway, that is, we've got the different types of meters, whether they're the clamp-on multimeter, whether or not they're the multimeter right here that does not allow to go ahead and have the clamp on. You have to go ahead and put the system, break open the circuit and put it in series to be able to read the current. So, there's different things that you've got to learn and know about a circuit. And the other thing that I want to address in this one lesson right here is the fact that you have to understand the fundamentals of a circuit, because let's just be real, okay? If you're going ahead and you're checking a circuit right here and say you check it, you set it to volts, well, there's AC, DC. So you need to know whether or not the circuit is AC or DC voltage. You need to know whether or not you're testing 120 volt, whether you're testing 240 or 480. Every one of them. So if you're testing 480 and it comes back and then it's reading 188, that's going to tell you that there's something wrong. So you've got to understand the systems before you can really utilize the ability of a meter. But let me give you a little story, just the importance of this right here, the meter, and why you should have it with you every time that you go out on a call. Back when I first started electrical, I worked, and I basically in the union, they started us out as a grunt. So, we had to go to classes and everything else, but, they had us doing all the grunt work, which was threading pipe, pulling wires. We were ohming out the wires, and tracing them down and stuff like that. Well, then I got to the next level, and then I was actually tying in and landing the wires into the lugs and everything. So I got up and I was doing a granary. So a granary has conveyors and everything, and it takes, the grain from these bins and it puts them on, boats and barges and things of that nature. So there's conveyors. So anyway, the electrical, the power station is a long way away from where a lot of the contacts and everything else are. So I was probably 140 feet away from the electrical station or the power supply that was sending the power up there to this motor starter that was supposed to turn on this motor that would turn on this conveyor to go ahead and load a barge. So anyway, I had a radio, I didn't have a meter with me or anything else. I called down to my boss. I said, now, are you sure you got everything turned off before I get into this electrical box right here and start wiring up this starter? And he said, yep, no problem. So I trusted him. And then I went ahead and I opened up the box. And what I had to do is I had another box right over here. And then I had to bring a conduit from there, bring these wires into this and drop them into the top of this motor starter. No big deal. So anyway, I had to, they got what's called knockouts. That's what, it goes ahead and it's just got a pre-punched hole that you just knock out with a screwdriver or a hammer or whatever. And then you can go ahead and put your conduit in there. Well, I had a hold of the screwdriver. Let's just say this was a screwdriver right here. And I had my hand on the metal part as well as on the rubber part. And I took the hammer, popped it, went through, knocked the knockout out, excuse me, and the screwdriver hit the lug. 480 volt. 480 volt hit me. Pow! Knocked me off a 6-foot platform on my back, knocked breath out of me and everything else. So long story short, if I'd had a meter to just go ahead and do what a person's supposed to do, verify that there's no voltage present, that everything's isolated out, then I'd have been fine. I mean, I'm fine now, but it's lucky, I could have got killed. I got knocked off that 6-foot platform right there, knocked the breath out of me and everything. But, by the grace of God, I'm still alive. But it could have been bad. So we want to go ahead and whatever you do, make sure safety's first and realize that this is your friend and you need to know how to use it and you need to know what it is that you're testing, what you should go ahead and read when you test it. And to do that, you got to dive in a little bit deeper. So if this interests you, hit that subscribe button and then watch the rest of this series. If you hit the subscribe, you'll go ahead and be notified every time that we have a lesson on this. And we're going to dig in deep and we're going to go ahead and then we're going to check out live circuits and show you actually how to do troubleshooting, how to use a meter. And I'll be looking forward to seeing you on the next video. Thank you.